And we're back. All right, so the next one is going to be complementary angles. You'll notice that it's two angles that add up to 90 degrees. So in the picture there that we have angle A plus angle B equals 90. The biggest thing is that they don't have to share the same vertex. In this example, they do right here. But you could have an angle of 30, an angle of 60. Add them together, you would get 90. So they don't have to share the same vertex, but they do have to always add up to 90 degrees. There's a little trick here. If you take the C and we make a little dash here, you notice that it makes a 90. So when you write complementary like C-O-M-P ... you take the C, turn it into a 9, helps you remember to get to the 90. So that's the really important part there. And then our next pair of angles here that's important is supplementary. Very similar concept. Two angles that add up together. Now it's going to be 180 degrees. So that's going to be the supplementary. So if you were writing out supplementary, S-U-P-P ... So what we do is we finish out the S, okay, turn it into an 8. The U gets a hat. If you're 80, you probably need a cane. And there's your 180. So remember, two angles that sum to 180, and that's a really neat takeaway. So the formula there is we just do part plus part equals 180, but just the two angles add together equal 180 degrees. So intersecting lines, remember lines intersect at one point. That's the really thing to take away there, is that lines intersect at one point. Lines intersect on one point. The next one, intersecting planes, is that planes intersect at one line. So let's back up. So we have, if we take this line and this line, they intersect at point B. So that would be the one point they intersect. So if we have plane Q and plane P, they intersect on line BA. So make sure those are two good concepts as well. These are like, I'm sorry at the beginning though, but there's a lot of TQ. TQ, 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 and then we have intersecting, when a line intersects a plane, it intersects at one point, so it just kind of punches through, boom, right there. So that's pretty easy. Midpoint. So the three magical words that will change your world is that it creates two equal parts. You'll hear me say it over and over and again, that it creates two equal parts. So our formula is going to be, so algebraically it's going to be P equals P. So if this is 4, this side is 4. So remember, it's the point that's in the middle. So M would be the midpoint, creates two equal parts. We'll learn that these are congruent marks. That tells us that segment AM is congruent to MB. So midpoint, two equal parts, point that's in the middle. I'll see it. There we go. There we go. Midpoint. So bisect, you'll notice that again, creates two equal parts. If you have that, our formula is always going to be P equals P. So different ways that you'll see it is that this would be where B bisects. So not quite, but it could be a segment bisector. So you would have congruent marks here and here. And then those are for segments. So those are your congruent marks notations. And then you have an angle bisector. And then these arcs tell you that the angles are congruent. So remember, bisect creates two equal parts. Could be a segment bisector. So I just drew a little, not the best picture, but that would be the segment bisector. And then you can have an angle bisector. So really important there. TQ. Congruent. So I apologize, but we kind of looked at what the notations there for congruent, but our words there are equal. That's going to be for congruent marks, but for polygon, same shape, same size. So what we have here is some colors. So we have BC. The one notation goes with the one notation. The congruent mark 1 and 1, so it says BC. segment BC congruent to FE. And then the 2 goes with the 2. So it would be segment AB is congruent to segment ED. So it's like if you were at a get-together and you want to know who's with who, you can see who the couples are. They're kind of isolated together. Well, we have the 3 goes with 3. Just know who goes with who. So remember, the congruent marks for segments are important. The number of dash marks or tick marks tell you who's with who's congruent to who. All right, congruent. Arc, you can just think of it as piece of the circumference. So you have the circumference all the way around, and arc is just a piece of it. So minor arc and a major arc. So we'll talk about that more when we get to the circles unit, but it's kind of good just to know what an arc is. Perpendicular, really important here. We're going to see it pretty soon as we get through it. So remember, there's 2 concepts there, intersecting lines at 90 degrees, and then the slopes are flipping opposite of each other. So if you remember, what that means is that if you have a slope of 3/4, it's perpendicular, so you flip it, 3/4 becomes 4/3. And the opposite means that if you have a positive, you're going to have a negative. So negative reciprocal is actually the academic terms, but most people don't use those. Flipping opposite gives you an action of what to do. So remember how to do perpendicular slopes. Angle is at 90 degrees. So really important there. And as we're finishing up here, here's kind of some regroup. Congruent angles, congruent segments. So remember, you have the congruent arcs, and then you have the dashes. The acute angle, right angle, obtuse angle. Make sure these are your special pairs of angles. So those are your special pairs. All of these are important. So TQs for all of those. So you have to be able to draw in special properties. Congruent to each other, crisscross, share the same vertex. Linear pair always creates 180 degrees, share a common ray. Adjacent, they don't have to be a straight angle. They just have to have the common vertex, common ray. Complementary add up to 90, supplementary add up to 180. The formulas you guys don't have to memorize, but we just know how to use them. The midpoint formula, so you take 2 points and you plug it into the formula. So we're taking the average of the points, and we'll work on that in class. The distance formula, pretty much we'll use Pythagorean, is what it breaks down to do the distance between 2 points, and it's very plug and play. So we take 2 points, we plug it into the equation. And down here, we have, here are your notations, TQ as well. Remember, the segment is just the bar. Ray is the bar with the arrow. Line has the bar with both arrows. Make sure opposite rays, you break them down into, you notice that they share a vertex. That's why they both have B. And then the direction that the ray is going forever in. So BC right here. And then you have BD. So this is a really good box there to look at. And review there of that intersection of 2 lines is at a point. The intersection of 2 planes is, remember, it's on a line. And those are really, so the last one is not as TQ concept as the first 2. So really make sure you know the first 2. All right, guys, that's it for the vocab. And so hopefully you enjoyed it. We will see you next time.